This month, New Tech Press goes to Scotland, land of kilts, scotch, bagpipes, haggis, and some of the most innovative technology you've ever seen. This report looks at
This is Lou Covey, Editorial Director of New Tech Press, with the 6th in our series of interviews with Scottish technology innovators. Today we'll be talking with Andrew Richards, the Director of Codeplay, not Coldplay, Codeplay, a software development platform for multi-core design. So, Andrew, what is Codeplay, what are you doing, and why is it important?
What we enable people to do is, mostly in video games, we enable people to offload performance-intensive work to something that runs faster than the CPU. And the thing is that in video games, you have to keep the action moving. So if you want to put something into a game and you can't make it go fast, it can't go into the game, because it will just make the action stop. You'd see it kind of stutter. So without our technology, it's very, very difficult to just get lots of new stuff going on in games. And because CPUs aren't getting any faster, we have to offload this work to other classes of device that can go faster. But the problem is you can't say to programmers, really carefully hand-tune your code for this weird new processor that we've just invented, because game developers, they're creative people. They want to come up with new ideas, just try stuff new, and so it's very difficult for them to do that. So we just enable them to use pretty much normal programming languages and normal tools, and we can just accelerate it on an accelerator processor.
Okay, so what we're talking about, well, let me step back a little bit. Jack Gansel in EE Times wrote this week that there's what he calls the multi-core with an N effect, in that the more processors you add to the core, the slower the actual performance is. So is that what you're talking about dealing with?
Yeah. Well, the whole point is to make it go faster.
Yes.
So that is what we deal with. Yeah, it's multi-core is very different in compared to all the other stuff. In the past, CPUs would just get faster, and as a software developer, you didn't have to worry about it. We would write games, and it would run too slowly. But by the time we'd finished the games, the CPUs had caught up, so it would run fast enough. So it'd be fine. In fact, if you wrote stuff for current generation CPUs, it would look ridiculously old-fashioned by the time you'd release the game. To finish the game, everything, the people who'd just put too much in, and the CPUs just saved you at the last minute. But now that doesn't happen. With multi-core, it just doesn't automatically go faster. And the problem is it does actually add these new bottlenecks in the system. So the classic one is memory. If you put lots of processors on the chip, yeah, you can do lots of processing, but they're all trying to access the memory bus at the same time. So yes, you can process data, but you can't actually get the data in and out, so it doesn't make it go faster. So it's just weird programming for multi-cores, because sometimes you do something that goes fantastically fast, and other times you do something and it goes horribly slow. It's very difficult to predict in advance whether it's going to go loads faster or loads slower. It's very scary for a programmer.
So are you already working with processor companies?
Yeah, we've been working with processor companies for a while now. So the companies that we can announce that we've worked with, like Qualcomm and Agea, we've been doing work with them to help their new processors. And Agea was an interesting one, because they came up with this idea: you put a physics processor inside a PC as well as a graphics processor, and you'd accelerate physics in computer games. So you'd have these explosions, and you'd have lots of objects that you kick around and break up.
Will this speed up the development of new games?
No. Yes, it will, but it'll speed up the development to do stuff. But I mean, the problem is development is getting larger. So it'll keep that increase in development size manageable. That's what it's going to do. Okay. We're not going to promise to make games faster than it was. I mean, when I started, it was just me and an artist working from home developing games. We'd do it in a few months. But now it's huge teams. So the problem now is that the teams have got so large they just can't get any larger. So we can put more stuff into the game and keep that development project manageable.
Now, is this only applicable to video games?
Right now, games is the biggest application for us. The games industry has pushed this more than anyone else. The technology has been pushed more than anyone else. But the interesting thing is that people are taking these graphics processors and saying, oh, well, we can use all this incredible processing power for scientific applications. And there are people doing it for scientific applications, and of course our technology would help in that. At the moment you have to accept that games don't have the same precision requirements. You know, in a game it has to look right. It doesn't actually have to be mathematically correct. It just has to look right. But what's happening now is that these graphics processors are being changed so that they are mathematically correct, which is less useful for games, but certainly very useful for these scientific applications.
Okay, well, what's your potential market for all this? As far as, let's get down to it. How much money do you think you can make?
I'm not going to put a number on it. I'm not going to put a number on it, but certainly, you know, we have this problem that the CPUs, in effect, are becoming less valuable. You know, if you look at the price and size of CPUs, they're actually getting smaller inside computers, whereas the value of GPUs is going up. So, but the next step for GPUs does require people to get much more complicated software onto these processors. And they are changing name from graphics processors to accelerator processors. And that's what we can enable. And without our technology, it's difficult to see what else there is to enable that to happen. So I mean, it is something that could be in every PC and in every video games console.
Excellent. Well, Andrew, thank you for your time. Looking forward to talking to you more in January. This has been Lou Covey with New Tech Press in Edinburgh, Scotland. Thanks for watching. This New Tech Press report has been brought to you by Scottish Development International and ITI Tech Media and DMB Associates of Scottsdale, Arizona.